Yeah, and thanks, ABS, for the opportunity to give this talk here. So what I've been asked to do is give a talk on water futures under climate change and some of the implications for irrigated agriculture in Australia. So I've put together a couple of slides to talk around, to give a background of Australian hydroclimate and water resource characteristics, and then go into the focus of the talk around what the future holds in terms of future droughts and water availability, touch a bit on the implications for agriculture, and then finish off with maybe some of the adaptation challenges and opportunities in this area here. So just as a perspective, that's how we look like compared to other continents in the world. We are the driest inhabited continent. We got the least water by far per square kilometer of land surface that we have. Having said that, Australia actually has amongst the world's highest per capita water use, comparable to Asia and the Americas. Well, it's not because you and I are drinking and guzzling lots and lots of water, but use water for things, industry, 70% of it for agriculture. So what we're doing is really we're exporting our water internationally also. Now, this is a slide I like to share because I'm a hydrologist, so looking at the hydrology or water perspective, this is how we look like compared to the world. Our hydrology is different. We got a low runoff coefficient. What that means is even in the temperate regions of Australia, less of our rainfall get translated to runoff compared to elsewhere in the world. We are also amongst the highest variability in terms of our river flows compared to the rest of the world. That's shown by the red marks on the left-hand plot. So Australia and Southern Africa have amongst the highest variability, twice more variable than elsewhere in the world. Just to put in perspective, if we want to get the same reliability of supply, our storages has to be 3 or 4 times bigger than storages in the Northern Hemisphere. So obviously we got significant challenges there. But with the same variability, it's also causing this predictability. So many of you would have heard about El Nino, Southern Oscillation, and teleconnection with stream flow or rainfall. So we and South America probably have the greatest possibility of predicting what might happen several seasons ahead. And the Bureau of Meteorology exploits this, and we actually have an operational seasonal climate and water forecasting system. The problem is I don't think we are really using the most of it yet, and we have to, over time, better and better use our seasonal forecast to manage the big variability in our system. And over here is what I tend to call the rainfall elasticity or stream flow, borrowing the term from economics. So as a general rule of thumb, we say that a 10% change in rainfall in Australia tends to be translated to a 20 or 30% change in stream flow. So any change that we see in rainfall is amplified 2 or 3 times in the stream flow. And that amplification factor is also larger here in the context of climate change compared to elsewhere in the world. And zooming down to Australia just very quickly, the first slide shows where most of the water is. So about 50% of the water is generated in the north, but most of the water in slide B is, we use water mainly in the southeast for good reasons. And that's, therefore, our catchments are most disturbed there, and that's where most of us live in the context of that. And if I or anyone were to put a picture about what's the biggest thing that's happening to the climate or hydroclimate in Australia, it's really this picture here, a really declining rainfall trend across the south and the east coast of and eastern seaboard of Australia. And as I said earlier on, any drying or any reduction in rainfall is actually amplified in the stream flow. So for those of you who are familiar with time series plots, this is the annual stream flows into the Perth reservoirs. It's quite amazing, remembering back from our statistical days, not a single year after 1975, you had an inflow to the Perth reservoir bigger than a long-term average prior to that. And we're seeing similar signs of that here through the William drought in the southeastern parts of Australia. I'll skip that. I'd rather talk about these in the context of we can explain some of the things that we are seeing. So that's a plot from the Bureau of Meteorology website. It is really a story of the decline in the cool season rainfall. So if you have a look at the plot at the top, we can't really tell much in summer. In fact, some parts actually been quite wet. But if you have a look at the plot during the cool season, my goodness, over large parts of the country, we have been dry and getting dry over winter. Now, there's been quite a few studies attributing this to some of the global warming that we have seen. In a warmer world, you get changes in circulation pattern, and that expands our Hadley cell and pushes the winter storm tracks, westerly fronts that we see in our systems further south, missing the South Australian landmass. And that's the main explanator about why we are getting a drier winter. And surprisingly, if you have a look at the global climate models, so these are models run across the world, and this plot really shows stuff from 42 global climate models run across the world by the Intergovernmental Panel on Climate Change. These models, at best, are notorious about not agreeing about themselves. There's a lot of uncertainty in this model, but look, they're all agreeing on declining winter rainfall into the future. So you got these multiple lines of evidence pointing to a drying winter. And the problem obviously gets worse as we go further and further south, because as we go further south, more of our rainfall is generated in winter. As we go further south, like in the state of Victoria, most of the runoff occurs in winter and early spring. So if most of your water that you get is in winter and early spring, and if I were to tell you that rainfall is going to reduce, then, well, we got a problem there. And this is what's driving a lot of the winter decline that we are talking about in the stream flow, in the water availability in the far southern parts of Australia. I think I'll skip that also with the rainfall projections, but suffice to say, we have modeling, we have ability to translate this, and we run a whole series of global climate models, dynamic downscaling, and catchment hydrology model, and we can convert that to sort of give you an idea of what might happen across the country. So this is our median projections about what might happen in the future, and unfortunately, the projections in rainfall is very broad. That's why you can see, colors ranging from the very dry to the very wet. I think very quickly you can tell that in the north, we probably have little idea about where it will head to, but in the south, you can see even the wettest projections of what might happen in runoff as very dangerous in the south. So it's likely that we've got to cope with less water in the south, anything ranging from now 0 to up to about 40% for 2-degree global warming. And that's expectations in about 30 or 40 years' time relative to pre-industrial time. So that's what we possibly need to start thinking about managing for. But it is challenging because of the big uncertainty around how it will protrude forward. Now, every time I put that plot, I tend to also like to show that it's not just an Australian problem. You got globally, people are concerned about a lot of things too. So if you were in an international conference talking about changes that's happening to the global weather and so on, or climate, sorry, the biggest signal that you see is not necessarily ours, but really what's happening in the Mediterranean, same like us, a drying and much more significant and much more clarity in explanation why it's happening in a warmer world. So they got a bigger problem in the Mediterranean. And the other big story is the big wetting and flooding in the mega deltas in the Indian subcontinent. They probably got a bigger problem being a poorer country, and I'm not sure how they're going to cope into the future. They're already seeing that, and they'll see more of that in the future. But beyond these two big signals, the third biggest signal is this signal that I'm talking about here, what we tend to refer to as the synchronization across the mid-latitudes of the southern hemisphere. So the drying that we are seeing, that we can explain partly of, is also happening in Southern Africa and in South America. So that's what we possibly have to learn how to manage and live with, the fact that we are likely to have less water in the southern parts of the country. Now, I'll do a bit of a pause here, and given that I did have agriculture in the title, maybe I might just mention that, it's not just a water thing. Climate change will impact agriculture in other ways too. So you got high temperatures, more hot days, more heat stress, reduction in cold days, you got winter chilling problem, and high temperature will also increase the irrigation water demand. So if supply is going down and demand is going up, the gap between supply and demand is also increasing. Now, one of the few things that we are more certain of is you definitely have higher extreme storm intensity, and that potentially have consequences also. You got a bit of a good news story. Higher CO2 may increase the yield, but possibly reduce agriculture quality. But at the end of the day, if you don't have water, you just can't grow food here. So it comes back to the whole water story. So I'll share this slide here by just putting a few pictorials up there on the fact that we had this millennium drought that has actually accelerated a lot of water reforms and policies that's been happening in Australia. And that has put us in a good footing, I suppose, to face what might be a challenging future. So I think you'll hear these more in other talks around improving irrigation water efficiency, using real-time hydrometeorology, the Bureau Water Information Division that was set up at the end of the millennium drought. So they had about 10 years, and now we've got real water information products, and all these are being used to actually enhance how much value we can get from our water. The other thing that Australia leads the world is water trading. So there are many papers out there showing that at the height of the millennium drought, we had only 30% of the water, so we used 70% less water, but in terms of agriculture money we made, that only dropped by about 20%. That's all about water trading shifting to higher value use. So we lead the world in that. That's a positive, but there's possibly some unintended consequences that can happen out of these too, but I'll leave that for another day. But the biggest thing, or the mother or father of all things that we have done, is really this water buyback for the environment. So under the Murray-Darling Basin Plan, we have bought back an equivalent of 1/5 of the consumptive water use and returned it to the environment to balance the use of water between irrigation and the environment. And obviously, the other options we always have is let's go and find more water. And that's largely in urban cities, so not directly probably related to the agriculture. I might share this penultimate slide, which talks about redressing the water balance in the Murray-Darling Basin, given that it's quite a topical topic. So what I've shown here, if you just can imagine, that pie chart represents possibly the long-term average total water that we have in the basin, let's say. So we've got a lot of parts of the basin that we are not managing the water, it's just unregulated water running in the system, but this part of the water is actually managed regulated water. Prior to the basin plan, the stuff on top, we got some minimum flows, but most of the water are actually being used for consumptive water use. So what the basin plan has done is we have bought back 1/5 of the nutrients that return to the environment, and that water is held by the Commonwealth Environmental Water Holder. The person who runs the Commonwealth Environment Holder has the same rights to water entitlement as these blue bits. So these people here, whether it's the environment or the consumptive water use, can use the water given whatever location they have and use it in any way they want. So that's returning a benefit back to the environment. But just for a perspective, under climate change, you know, the big range of projections I was talking about, if I use the median projection, that amount of water under climate change will be similar to the water that's being covered there for the environment. So clearly we've got to learn how to make even better use of the water. But ultimately, as we move forward, we've got to have the serious conversation about what do we want to do under climate change. I think the authorities are aware of this, and you get the whole Murray-Darling Basin Authority has set up a climate change risk program to start thinking about this very seriously. If your pie is shrinking, what are you going to do? Because it's not just one party, or all users will be suffering from the shrinking of the pie, and we still got to come back to redress what are we going to do about that. So I'll just finish off with this last slide around some of the challenges and opportunities. So I think we know it's very likely that we've got to deal with this. Perth has already decided that we're not going to wait for evidence, we're just going to deal with it as normal surface water, whereas here we still got a challenge that we are addressing. So what can we do about that? I suppose you can always go and find more water. I'll probably leave that conversation for another day. We can learn how to use water better. So find out now how to water the environment better, figure out which assets we want to protect, and so forth. We can always improve irrigation water use. And there's certainly a lot of innovation here. We talk about this conference being trying to enhance the value to $100 million. You heard quite a bit about that. It's quite interesting that some of these things here, like crop breed, new technology, better agriculture practice, over the millennium drought, over the last 20 years that Australia has been having a drying climate, as you saw in today's plot, the amount of money made from agriculture has actually increased slightly, despite all these reductions. Well, that's from two things. And we learn from technology and things like that. The other one is making more value out of the crops we grow. So we've got to learn how to do this, because we're not going to get more water to be able to do that, but to actually use water more wisely. Obviously, we can have market instruments and policies. I think there's smarter people or people who know more about this in the room, and they can address that elsewhere. We got to be careful about the unintended consequences also with these policies. I won't steal Chris's thunder. He'll tell you everything about why and why not in Australia, I'm sure. But ultimately, I'll just finish off with some of these changes we're talking about. If some of the extreme end of drying projections are realized here, I think we have to sit down and talk collectively about what we really want as a nation, what values we hold, and what are plausible to achieve in the future from an agriculture, from an environment and industry perspective, and work out mechanisms or policies about how to transition to get there. And I might finish there, Warwick.